So now we'll start looking into the parametric technique of making drawings. So parametric technique is not new and it is used in many softwares, but in AutoCAD it was introduced somewhere around year 2010. Now the parametric technique is a simple method in which drawings are made with the help of constraints or restrictions. Now these restrictions are applied on different mating parts. To explain this concept, I'll use a sample drawing. Now here in this drawing we have two similar geometries. In the first case, no parameter or no constraint has been applied, but in this case there are some constraints which are applied in between different parts of the geometries. Now in this case, if you select the geometry, you'll be able to stretch it, you will be able to modify it using these multi-function grips. Also, if I select the circle, I'll be able to modify its geometry, and all of these changes are independent of the remaining geometries. Now let's move on to this part of the geometry. In this case, if I select the geometry, the grips will be highlighted obviously, but if I try to move the geometry with any of these grips, they behave in a particular fashion, and in this case rest of the geometry is also moving with that, it's not deforming. So I'll press Ctrl Z, and now in this case also, if you look at these two constraints which look like dimensions, they are quite dependent on each other. Now let's say that here we have the radius 1 as 25 and the radius 2 for this arc as defined by this formula. Now they are completely dependent on each other, and if I change radius 1, it will change automatically. So I'll double click on this and I'll change the radius 1 to 40, and now as soon as I press enter, you'll notice that the complete geometry reacted in accordance with the change, and in this case the arc length increased and also rest of the geometry changed because the parametric constraints are applied in between different parts of the same geometry. So that's the difference between a simple geometry and a parametric geometry. Now these parameters or constraints are applied with the help of parametric tab. So I'll press Ctrl Z to get back to the original drawing, and now here when you go to this parametric tab, you'll see all the tools which are related to this parametric technique. Now in this case we have this geometric panel on which all the geometric constraints are listed which are related to the geometry obviously, and in this panel we have the dimensional constraints which are related to the dimensions, for example the linear dimension, the radius, the diameter or the angle. Also we have another panel here which is manage panel, which will be used to add formulas and other features to the parametric drawing. So we'll learn about all of them in the upcoming videos. In this video, I will tell you about creating the parametric drawing with the help of Infer Constraint status bar option. So right now we have this simple drawing which is not made with constraints, and we'll make a copy of this drawing but with the help of constraints or restrictions. So when you go to the status bar, here you will see this Infer Constraint option, and if you are not able to see this option, then go to the customization on the end of this status bar and select this Infer Constraints. So that will activate the Infer Constraints option. Once the option is visible, click on it to activate it. Now I'll go to the line tool and click anywhere in the drawing area to start making the line, and now start by adding the length to this line. So I'll use approximate distance in this case, and also as you can see that we have this dynamic input activated, so I'll simply deactivate it. So I'll once again go to the customization and I'll select dynamic input and I'll turn it off. Okay, now we have simple dimensions here. So I'll click here, and as soon as I click here, you'll notice this small box. So that's an automatic constraint which is applied because Infer Constraint option is active. Now I'll move here, and once again a new constraint has been applied. Now I'll click somewhere over here, again a new constraint, click here, and you'll notice that new constraints are automatically applied in all of these cases, and I'll join it with the initial point, and now I'll press enter. So now we have these constraints applied on different points. All of these constraints have their specific purposes. For example, when I go to the first one, which is the horizontal constraint, its purpose is to keep this line always horizontal. So in this case, no matter how you change the grip, the line will always remain horizontal. And in order to show it clearly, I'll make a simple geometry, a simple line, And once again, we have the horizontal constraint here. Now as the constraint is applied, when you select the line and you try to change it, you'll notice that you won't be able to do so. Even when the position of line changes, it will always remain horizontal. Now similarly, we have the second constraint, which is perpendicular. Now I'll erase this line and I'll go to the line tool again, and now I'll start with this point and I'll click here. Now we have the perpendicular constraint. Now this constraint has been applied in between this line and this line, and in this case both of them will always remain perpendicular no matter what. So I'll select it and I'll try to rotate it, and when I do so, you'll notice that it will move but it will not rotate, and it will also not change its position. So although the length will change and all the other geometries will change in this case, but you'll notice that the relationship or the constraint which has been applied to these geometries will always remain maintained. So it's still perpendicular and this line is still horizontal. So in a similar way, all of these constraints are applied on this collective geometry and they will always maintain their relationship with this complete geometry. Now we have this circle also. So let's go to circle and let's make it. So I'll take reference of this one and I'll reference the center point here, but the midpoint is not visible. So go to the object snap and turn on this midpoint. Now go to this point and here we have it. Now I'll make the circle, and in this case no constraint was applied on this circle. In this video, I will tell you about applying the geometric constraints to the geometry. And here we have the simple geometry. Now, in order to apply the geometric constraints, once again go to the parametric tab, and now here we have this geometric panel on which we have all the tools related to the geometric constraints. Now let's start by constraining some of the parts of this geometry. Here in this case we have this rectangle, we have these two circular geometries, one of them is arc, one of them is circle, and let's say that we want to keep this form of the geometry. In this case we want to keep these two lines parallel and also these two lines parallel. Also we want to retain the perpendicular lines here, and we also want all of these geometries to remain connected as they are from end to end. Now in order to do that, I'll start with the parallel geometric constraint. So I'll go to the geometric panel and click on this parallel, and now select the first set of lines. So I'll click on this one and this one. Now the parallel constraint has been applied in between both of these lines. Now let's select this line and let's move it. And you'll notice that yes, we have both of these lines parallel, but in this case these two lines are not parallel as the constraint is not yet applied. So let's press Ctrl Z, go to the parallel and click on this set of line, and now select it and click on any of these grips and look at geometry. When I deform the geometry, the constraint will be maintained. These two are parallel and these two are always parallel, but we have a problem here. In this case, this arc is losing contact with these two endpoints. So in this case, we need to make them coincident. So let's press Ctrl Z, and now I'll go to the geometric panel again, and here we have the coincident constraint. So that will ensure that the endpoints remain connected. Now I'll go to this line and close to the point which we want to connect, and we'll see this red marker. When the marker is visible, click. Now go to the arc, and once again when the marker is visible, click. Now we have this blue dot which indicates that a coincident constraint has been applied. Similarly, repeat the process for this side. So I'll go to coincident, I'll go to this horizontal line but close to this endpoint, click on this arc close to the endpoint, and we have the constraint. Now let's deform the geometry, and yes, in this case we have the constraint maintained even though the geometry is highly deformed. But now in this case you'll notice that the angle is not 90 degrees for all of these lines. That means we need to apply a perpendicular constraint. So I'll press Ctrl Z and I'll go to this perpendicular constraint. Now click on this line and click on this line, and the constraint is now applied. Now let's click again, let's try to deform it, and yeah, we are not able to deform it. We have it fully constrained, except for one thing, we are able to move this drawing. Although the consistency of the geometry is now maintained, but we don't want it to be moved to any other place. For that we can apply fixed constraint. So let's go to the fixed constraint, and now I'll click on any of the vertices, and that vertex will be fixed. So as that vertex is related to remaining part of the geometry, they will also remain fixed. Now I'll try to move it, and yes, we have almost constrained drawing. So even if I try to move this geometry, most of the parts are now fully constrained and I'm not able to move them. Now in this case, if you want to hide all of these constraints from your drawing area, you can simply do that by selecting this hide all option. So click on hide all, and the complete constraint is now hidden. In order to bring it back, click on show all. You can also selectively show and hide these constraints, and for that select this show hide option. Select the geometries on which the constraints are applied that you want to hide. So in this case I'll select this line and this arc, and now press enter, and now we have some options here. So we have this hide option. Let's select hide, and the constraints of these two geometries are hidden. In order to bring them back, once again click on show all, and the constraints will be visible. You can obviously select this cross icon, so that will also hide these constraints selectively. So you can click on these cross icons to hide them manually if you want. So that was all about applying the geometric constraints in your drawing. In the next video, we'll learn about applying the dimensional constraint to this drawing. In this video, I will tell you about applying the dimensional constraints on the geometry. So in the previous video, we learned about applying these geometry constraints. Now we'll add some dimensional constraints. Now in this case, I'll start with this dimensional panel, and here on the dimensional panel, when you expand this flyout, you'll see some constraints which are quite similar to the dimensions which we have already seen. So we have the linear, horizontal, vertical, all of these constraints. We also have the aligned, the radius, diameter, angle. So all of these constraints can be applied on the geometry. So I'll start with the linear constraint. So let's go to this linear and now move close to this end of the horizontal line. So in this case, you can see the highlighted marker. Let's click. Now let's click on the second point which is close to the vertex, and here we have it. The linear constraint is now applied, and as you can see that it has a identifier D1, which is for distance 1 obviously, and we have this constraint applied. Also the log sign indicates that it is now restricted to this length. If you want to apply a new constraint on this side, so you can do that as well. So I'll go to this vertical option, and now I'll click close to this end of the vertical line. So make sure that you are clicking only on the vertical line, not on this horizontal line, because we want to apply it on this one. And also make sure that you are not clicking anywhere close to this center point, because in that case another marker will be highlighted. So now I'll click close to this point, and I'll click close to this point, and I'll place the constraint here. So we have the horizontal and the vertical constraints now applied. In order to apply any aligned constraint, you can select this aligned option. Also we have this option here, radius. So let's select the radius constraint and let's apply it on this arc. So I'll click here and I'll apply this radius constraint just like this. Now let's repeat the process of this radius constraint and let's apply it on this circle. So I'll click on this and let's place it somewhere over here. And we have this radius also applied here. Now in all of these cases, all of these are the constraints, and you can see that they are quite different from the dimensions which you apply. Now if you want to change their shape and if you want to use dimension type of constraints, then you can change that from this flyout. So expand the dimensional panel, and here you will see this annotational constraint mode. So right now dynamic constraint mode is selected, that's why we are seeing this dynamic constraint. So I'll change it to annotational constraint. And now let's remove some of these. So I'll select this radius, I'll remove it, and also remove this vertical one. Now I'll once again apply it. So I'll go to radius and click on this circle, and now here instead of this kind of dynamic constraint, you'll be able to see the constraint which is similar to the dimension style. Although this is still a constraint, but the dimension style will be taken up in this case. Also if you want to apply it here, let's select the vertical, let's apply the vertical constraint, and once again it's taking the properties of the dimension style, but still as I mentioned it's a constraint. In this case also, if you want to hide the constraints, you can simply select hide all for all of these dimensional constraints, and if you want to reveal them back, you can click on show all. But as you can see that we have these as annotations, or the dimensions, they won't be hidden. In order to have a uniform distribution of constraints, I'll simply remove them and I'll apply the dynamic constraints instead. So I'll select the dynamic constraint mode and I'll once again apply the constraints on these geometries. So here we have the radius constraint applied, and also we have here the vertical constraint. So let's apply it here, and we have it now. So now when you hide the geometries, the complete constraint, the dimensional constraints will be hidden. Also when you click on show all, they will be revealed back, and if you want to hide or show them selectively, you can select show hide, select the geometries, now press enter and select hide, and the respective constraint will be hidden. To bring it back, click on show all. So that was all about the dimensional constraints in AutoCAD. In this video, I will tell you about the use of parameters manager and formulas in AutoCAD. So we have this simple drawing which we have made in the previous lesson, and in order to apply different formulas on different parts of this geometry, we'll once again go to this parametric tab. Now on this tab we have this parameters manager here. So now click on this parameters manager, and this parameters manager palette will pop up. Now here we have this list of all of these constraints, the dimensional constraints which we have applied in the previous videos. Now these constraints are also available on this geometry, but they are not visible. In order to show them, or in order to make them visible, click on show all button on the dimensional panel. So now it will make all of these dimensional constraints visible. Now in this case, you can see that this radius 2 value is close to 25.98, the radius 1 is 31, d1 is 145, and d2 is 87.37. so now all of these are independent values. They are not dependent on each other, but we can make them dependent. So we'll start by adding our own parameters, and then we'll add different formulas to make these dimensions dependent on each other. I'll explain it here in this parameters manager. So here on the parameters manager, click on this fx icon. Now this will add this new user parameters. Now here type area, and that will be the name of our new parameter. Now we have an expression value here which is set to 1. So let's click on this, and now let's type the expression value, and we'll use the area of this circle, which is this one. So in this case, I'll type pi multiplied by radius, which is radius 2, and that's the name of this parameter here, or this dimension here. This radius is known with the name of radius 2, that's why I'm entering radius 2, and then this caret sign. So this caret sign is available on your keyboard. So when you press and hold shift key and press the 6 key on the number bar, you'll see this caret sign. Now after that, type 2. So this formula indicates pi r square. So here we have this pi multiplied by, which is indicated by this star mark, radius 2, which is this radius, and the square is indicated by this caret sign. Now radius to the power 2. Now once this is done, simply press enter, and now you will see the final result here. So the area of this circle can be seen here in the value. So now we have one of the parameters defined. Now let's define another parameter, which is area of this complete rectangle. Although in this case we have this part of rectangle missing, but let's assume that we want the complete rectangular area. For that, I'll click on this fx again, and I'll add r area, that is for rectangle area. And now the rectangle area will be equal to length multiplied by width. So that will be simply d1 multiplied by d2. So here I'll click in this expression column, and now I'll type d1 multiplied by d2 and simply press enter, and we have the final result here. So now we have the area of circle and the area of rectangle. Let's use these values and let's apply them on this geometry. So now the first thing that I'll change in this case is this d2 value. In this case, let's say that we want to keep d2 value always half of the d1 value. For that, go to this d2 here, and here we have this expression. Let's double click here and let's change it to d1 by 2, and now press enter. And as soon as you'll do this, you'll notice that the value changes here also, and also the geometry will respond in an appropriate way. Now the value of this length will decide the value of this width in this rectangle. Also we have this radius value. Now let's use this radius value to decide the length of this rectangle. And in this case, I'll simply go to this d1 value, double click on this, and I'll type 5 multiplied by radius 2, and now press enter. So now the length of this rectangle will always remain 5 times that of this radius value. Now our geometry is getting a little bit deformed, so in order to make it appropriate, I'll change this radius value. So I'll double click on this radius and I'll change this value to 24 and press enter. Now with respect to the size of this rectangle, the circle is still very large, so I'll change one more parameter here. In this d1, I'll change this 5 to 8, and now press enter. Now we have an appropriate rectangle. So now the d1 length is always equal to 8 times that of radius. Okay, so now we have most of these parameters applied on this geometry, and now you can simply see how these values are connected with each other. In this case, if I change the value of this radius, this will change the value of length because it is dependent on that. As you can see, that d1 is equal to 8 times of radius 2, and when this length changes, it will change the length of this line here or the width of this rectangle, because d2 is always equal to half of d1, which is this one. So changing a single parameter will change all of these values using this parameters manager. Now in this case, you can see that we have not applied any formula on this case. Now if you want to apply any of these formulas, you can do that as well. And for changing the value of this radius, we'll use these user parameters. So we have defined these two parameters. Now let's say that we want to keep radius of this circle always equal to 100th time of this area. For that, I'll simply go to this radius value, the radius 1, and now let's type area by 100 and now press enter. And now you'll notice that the radius will change appropriately, and in this case the radius will always remain 100th time the area of this circle. So now they are completely dependent on each other. Now in this case, if you want to add more formulas, if you want to make it even more complex, you can add that also. For example, let's now double click on this and let's increase this radius value to twice of its original. So in this case, I'll add this bracket along this complete formula, and now I'll add 2 and add this star mark. So that will make the complete radius twice of the value which we have already assigned. Now press enter and here we have it. So in this case, 100th time of the area of that circle multiplied by 2 is equal to the radius of this circle. So that's a little bit complicated formula, but yes, you can apply these formulas and even more complicated formula that involves logarithmic or trigonometric values also using this parameters manager. So here we have the question related to this module. Now here we need to make a rectangle with length 10 unit and width of 5 unit. Now make a circle with radius 1.6 unit and make it at the center of the rectangle. Now add constraints to this geometry in such a way that the width of rectangle always remains half of the length of rectangle, and also the constraint should be applied to keep the circle at the geometric center of the complete rectangle. In this case, assume that the lower left corner of the rectangle is fixed. So here we have the blank drawing. Let's start by adding the rectangle. So I'll go to draw panel, expand the flyout, select rectangle, click at a point. Now type at 10, 5 and press enter. Now we need to add the circle at the geometric center. So go to circle and now go to this point, but don't click and drag it here. Also you can go to this point, then drag it and click on the geometric center. Although in this case I directly have the geometric center snap, but if you don't have that, you can use this object snap tracking option. Now enter a radius of 1.6 unit and press enter. So there we have it. The geometry is now prepared. Now let's start by adding the constraints, and for that I'll go to this parametric tab. Now here we have the linear, constraint and align. So I'll select this linear. Now click close to this endpoint and then click close to this endpoint and apply the constraint. So there we have it, the 10 unit length. Now go to linear again, click close to this endpoint, click close to this endpoint and apply it here. Okay, so we have applied the linear constraints, but we need to ensure that this rectangle remains like a rectangle, and for that we need to add parallel constraints also. So I'll go to geometric and I'll select this parallel constraint. Now select these two lines and there we have it. Now repeat the process for the vertical lines. So I'll select these two and there we have it. Now we need to add one more constraint to constrain this circle at the center, and for that I'll select the linear again. I'll click on this circle and that will select the center. Now click on this point, but in this case make sure that this center point is highlighted, and there we have it. So right now all of these constraints are added, but still they are not dependent on each other. So in order to make the dependency as per our question, we need to add formulas. So the first requirement was the width, and the width should always remain half of length. So in this case you can see that the length is d1 parameter, so the d2 parameter should be half of that. So I'll double click on this
and I'll change this value from 5 to d1 by 2 and press enter. So apparently it will not make any change in the geometry, but now if you change the length here, it will automatically change the width. Similarly, in this case, you need to ensure that this d3 value remains always half of this d1 value. Or you can also say that this value, this d3 value should also remain equal to d2 value. So I'll simply double click here and I'll change this value to d2. Okay, so there we have it. Now we have these three parameters defined. We only have one parameter, which is the fix parameter that should be defined for this point. So I'll go to this fix geometric constraint, click on this point. Now we have it defined as per our question. Now let's check it. So I'll double click on this and I'll change its length to 16 and press enter, and there we have it. Now in this case, the length changed the width and the width changed the distance between the center of the circle and one of its vertical lines. And all the constraints are properly maintained.